free test. White had a variant on this. Okay, Hubert White had a variant on this. What White said is, White's test is basically the same test. White's test is basically the same test, but the regression that White will run will be like this. So what White will include is not only Z1, Z2, Z3, but squares of Z1, square of Z2, square of Z3, their products with each other and so on and so forth. So what White will do is will look for a more general relationship between the variance of the error term and the explanatory variable Z1, Z2, Z3, right? Now, if k goes up, then n minus k becomes smaller. Then the numerator will become bigger. So 1 minus that will become smaller. Right? So you see this guys? So basically how will you test this now? The method is the same. So क्या करेंगे? How will you do this test? कैसे करेंगे? अभी सीखा ना अपन ने कुछ. So what will be the null? What will be the alternative? A1, A2, A3, A4, A5, A6, A7, A8 are all 0. Again the alternative that at least one of them is not equal to 0. One of them is not equal to 0. Right? At least one of them is not equal to 0. So क्या टेस्ट क्या रहेगा उसका? अगर f करेंगे तो न्यूमरेटर डिग्री ऑफ फ्रीडम कितनी रहेंगी? 8 and the denominator will be n minus 9. बट अगर f नहीं चलता है तो अगर एंगल्स LM टेस्ट करना है या BPG टेस्ट करना है तो क्या रहेगा इसमें? और वाइट्स टेस्ट करना है तो you will do the regression degrees of freedom into the R square. Degrees of freedom, not 8, degrees of freedom. So n minus 9 into the R square of this regression will be a chi-square distribution with 8 degrees of freedom under the null hypothesis. So you will, if you reject that null hypothesis, if you have little evidence to say that, then you will reject the null hypothesis. So you have to compare to the chi-square. Right? Is this clear, folks? This is White's test. Right? So this is how you test for heteroscedasticity. To test for autocorrelation हो गया, test for heteroscedasticity हो गया, and I am going to trouble you a little bit more by talking to you about dummy variables now. Right? Because we still have about half an hour, no? No? So let's then discuss this. Any questions on this? No. In all these respects, you only have the chi-square. The f cannot be applied generally because you don't know whether error terms are normal. So both, but in White, you have a more general, so you have a Z1 square, Z2 square, Z3 square, their products also. Whereas in the BPG test, you have just Z1, Z2, Z3. Both of them are using the Lagrange multiplier principle. Right, so basically these tests came first, and then Robert Engel showed that all of them were actually just the LM test. So a huge number of tests in econometrics became LM tests, Lagrange multiplier tests. Yeah? It's called Engel's LM test. And I had actually one student in class many years ago who actually derived the same result as Engel did in class. Yes, he actually showed to me in class on a piece of paper why Engel got the result that he got. Yes, so sometimes you have very bright students in class. Sure? So is this okay? Everybody follows this? Any questions? So what is the difference between R square and adjusted R square? Because the adjusted R square adjusts for the degrees of freedom. That's what's called the adjusted R square. The adjusted is adjusted for degrees of freedom. Right? Can you show, suppose I wanted to test for the significance of the R square of a regression model. Can you show me that the R square actually follows an F distribution? Testing for the R square. So I've got some R square which is 0.003. I want to test whether it is statistically significantly different from 0 is actually 0. How will I take a test of hypothesis on R square? Is the R square statistically significantly different from 0? Is suppose I want you to ask them. How will you test that? Try to do it at home. Clear? Are we done? The attendance sheet? So thank you folks.